All right, the last topic we're going to cover, it's going to be covered in two different videos, is just operations with polynomials. So we've looked at what polynomials are, we figured out how to graph them and identify some of the key features of polynomials, and now we're going to take a look and identify how to do operations with polynomials. So for today, we're just going to look at adding and subtracting. So make sure you put today's date in the top corner of your notes. So for these problems, we're just going to jump right into the examples. So remember, polynomials are when you have terms that you're adding together that have positive exponents. So let's look at some examples for adding. Let's say I gave you this problem. 5x to the third minus 2x plus x squared plus 7. That's one polynomial. And we're going to add it with 3x squared plus 7 minus 4x. So notice there's a plus sign in between. So that means I'm just adding the terms in this polynomial with the terms in this polynomial. The way I like to approach this problem is to identify the like terms using the exponents. So I'm going to start over here, and I have 5x to the third, and I'm going to go in order of highest exponent to lowest exponent, because that helps keep my answer in standard form. So the highest exponent here is 3. So I'm going to see if there's any other x to the third term that I can add in this polynomial. So I don't see anything, so I'm just going to rewrite that one down, 5x to the third. All right, so now after x to the third, I look at my x squared terms. So I have 1x squared here, and I have plus 3x squareds over here. So 1x squared plus 3x squared is 4x squareds. Then I look at just an x term. So I have negative 2x plus negative 4x. So negative 2x plus negative 4x, that gives me negative 6x. And then finally, I look at the constants, the values that don't have any letters attached to them. So I just have 7 plus 7, which gives me 14. So when you're adding polynomials and you're subtracting polynomials, in the summary here, all you're really doing is just combining like terms. You look for the things that have the same values in terms of their exponent and variable. And when you're adding, you're just combining by adding the things over the parentheses. So let's take a look at two more examples. Let's say I gave you 4x squared minus 7x plus 2 plus negative 8x squared plus x minus 2. So just like in the first problem, I'm just going to combine like terms, and I'm going to add the things that have the same exponent and variable. So I have 4x squared plus negative 8x squared. So 4 plus negative 8 is negative 4x squared. Now I have negative 7x plus 1x, so that gives me negative 6x. And 2 plus negative 2 is 0, so I don't have to write that. So there's my final answer. When I combine like terms there, when I'm adding the two polynomials together, that's what I end up with. All right, and then one last problem. So I've got negative 8m squared plus 2m minus 3 plus the other polynomial m squared plus 5m. So again, I'm going to look for the like terms. So I have my m squareds. So I have negative 8m squared plus m squared, which would be negative 7m squared. Then I have 2m plus 5m, which is 7m. And then the negative 3 doesn't have anything to add with, so I just leave it as negative 3. And that's combining like terms and adding the polynomials together. So those are problems with addition. So addition is when you see the plus sign in between the two polynomials. Let's look at some examples with subtraction. So let's say we had the polynomial negative 2x to the third plus 5x squared minus 4x plus 8 minus negative 5x to the third plus 3x minus 4. All right, so when you're subtracting, you got to be careful, and I think an extra step with subtracting will help. So when you're subtracting, it's probably actually easier to get rid of the parentheses and distribute this negative. Because if you think about it, there's like a negative 1 here that we can distribute to each of the things in the side of the second parentheses. So the first parentheses just stay the same. So we're going to drop the parentheses, but now here I'm going to distribute this negative 1. I'm going to be taking it away. So minus a minus is a positive, so I have plus 5x cubed minus 3x plus 4. So that minus sign just changed the sign of each of the things in the second polynomial. And now it's just adding the like terms that we did from the first kind of problems. So I have my x to the third term with my x to the third term. So that's 3x to the third. I have 5x squared, but there's no other x squared term, so that's all by itself. Negative 4x minus 3x, so that's negative 7x. And then 8 plus 4, so my final answer here turns into that. So the only difference in subtraction is that I have to distribute this negative to each term inside the second parentheses and then just combine like terms like you normally would have. And that's subtracting. So let's try to take a look at 2 more examples, and then I'll give you guys time to practice your problems. So let's say I had the polynomial 7x minus 2 minus the polynomial 9x minus 3. So same thing with subtraction. 7x minus 2 stays the same, and I'm going to distribute this negative 1 minus 9x plus 3. I'm just going to change the sign of the second polynomial, all the terms in there. And now it's just combining like terms. 7x minus 9x is negative 2x, and negative 2 plus 3 is 1. And then last example, 3x squared plus 2x minus 4 minus 2x squared plus x minus 1. I'm going to drop the parentheses, so these terms in the first set stay the same. But now all these ones back here change their sign. So negative 2x squared minus x plus 1. So now I just combine like terms. 3x squared minus 2x squared is 1x squared. 2x take away 1x is 1x. And negative 4 plus 1 is negative 3. So adding, subtracting polynomials is really just combining like terms. The tricky part is just working with the subtraction, and remember to subtract with the second polynomial that you're distributing a negative 1 and using opposite operations, opposite signs for those terms. Okay, so you should be able to work on adding and subtracting polynomials.